Hi everyone, so today I'll be going through the data analysis section of the 2018 for the Maths Exam 1. Question 1, the dot plot below displays the difference in travel time between morning peak and evening peak travel times for the same journey on 25 days. Percentage of days where there was a 5-minute difference in travel time between morning peak and evening peak travel times is. So over here on this axis we have the difference in travel times, we want to find the percentage of days when there's a 5-minute difference in travel time. So we look over here, we know that 5 is here. So we just count the number of dots on number 5, on number 5 for the difference in travel time. So 1, 2, 3, 4, 5. We want to calculate the percentage of days where there was a 5-minute difference in travel time. So we know that there were 5 days that had a difference in travel time of 5 minutes. You do that over the total number, which was 25 days. To convert that to a percentage, you just multiply that by 100. If you put that on your calculator, you'll get 20%. That's the percentage, so therefore C is the correct answer. Question 2, the median difference in travel time is. So I just wrote the formula for the median over here. So it's n plus 1 over 2. We know in the question that the value of n is 25, which was the travel time recorded for the 25 days. So m equals 25 plus 1 on 2. That will give you 13. So you count 13 from the lowest point. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So 13 is here. So therefore, if you count 1, 2, 3, we know that the median difference in travel time is 3. So therefore, A is the correct answer. Question 3, the pulse rates of a population of Year 12 students are approximately normally distributed with a mean of 69 beats per minute and a standard deviation of 4 beats per minute. The student selected at random from this population has a standardized pulse rate of Z equals negative 2.5. This student's actual pulse rate is. So I've written the formula for finding a Z score over here. So basically this represents the actual value minus the mean on the standard deviation. So if we sub those values in from the question we know that the Z score is negative 2.5. So you put sub Z is equal to negative 2.5. We want to find the actual value over minus the mean. The mean is 69 beats per minute as we have given in the question over here. On the standard deviation, we know the standard deviation is 4 beats per minute as given in the question. So if you solve for x on your calculator, you'll get 59. So we know the actual pulse rate is 59 beats per minute. So therefore A is the correct answer. Question 4, another student selected at random from this population has a standardized pulse rate of Z equals negative 1. The percentage of students in this population with a pulse rate greater than this student is closest to. So we know that the Z score is negative 1. Basically, this suggests that the student's pulse rate is one standard deviation below the mean. So if we have the mean is over here, we know that this value over here is 1 standard deviation below the mean. So for example, if Z equals 1, we know that this would represent a pulse rate of 1 standard deviation above the mean, and we would know that this value over here is 1 standard deviation above the mean. So in the case of the question, we know that the pulse rate is 1 standard deviation below the mean. So therefore, we look at this value over here, and we want to find the percentage of students in the population that have a pulse rate greater than this student. So we look at all the percentage of pulse rates that would be greater than this. So you just add 34, 34, 13.5, 2.35, and 0.15. If you add all of that together, so 34% plus 34% plus 13.5% plus 2.35% plus 0.15%, which would equal 84%. and therefore E is the correct answer. Question 5. A sample of 200 students was selected at random from this population. The number of these students with a pulse rate of less than 61 beats per minute or greater than 73 beats per minute is closest to. So we know that the mean is 69 beats per minute and the standard deviation is 4 beats per minute as given in the question. So we want to find out the number of students with a pulse rate less than 61 beats per minute or greater than 73 beats per minute. So to do this question, you know that the mean is 69 beats per minute. So we want to find where 61 beats per minute is on the normal curve, on the normal distribution, sorry. So if you do 69 minus 4, that would give us one standard deviation below the mean, which is 65. So one standard deviation below the mean is 65. If you do 65 minus another 4, which is the standard deviation, that will give you 61. So that's what we found. We want 61 beats per minute. So we know 61 beats per minute is 2 standard deviations below the mean. So 61 beats per minute is 2 standard deviations below the mean. So we know that the percentage of these students less than 61 beats per minute would be 2.35% plus 0.15%, which is 2.5%. And we also want to find the number of students with a pulse rate greater than 73 beats per minute. So if we find what one standard deviation above the mean, that'd be 69 plus 4, which is 73. So there we have it, 73 beats per minute. So we know 73 beats per minute is one standard deviation above the mean. So the percentage of, one standard deviation above the mean. So we want to find the percentage of students with a pulse rate greater than 73 beats per minute is 16%. So if you do 16, sorry, my working out up here. So if you do 16% plus 2.5%, that'll give you 18.5%. So we have a sample of 200 students. We want to find of those 200 students, how many had a pulse rate less than 61 beats per minute and how many had a pulse rate greater than 73 beats per minute. So if you do 18.5%, which odd 100, so to represent as a percentage, times the sample, which was 200 students, put that in your calculator and you'll get 37. So we know that 37 students had either a pulse rate less than 61 beats per minute or greater than 73 beats per minute, so therefore B is the correct answer. Question 6. Data was collected to investigate the association between the following two variables: age 29 and under, 30 to 59, 60 and over. Uses public transport, yes or no? Which one of the following is appropriate to use in the statistical analysis of this association? So this variable over here is a categorical variable, as we have 29 and under, 30 to 35, and 60 and over. So there's categories there, and there's obviously a clear order to them. So 29 under, then 30 to 59, and 60 and over. So there's an order to the age. So therefore it's a categorical ordinal variable. And this variable over here is a categorical. So it's either yes or no, but it's a nominal variable because there's no order. So I've just taken a photo from my notes over here. And so we know that if there's two categorical variables, categorical, that means a segmented bar chart or two-way frequency table would be used. So therefore we have a segmented bar chart over here, but we don't have a two-way frequency table in our options. So therefore D is the correct answer. Question 7. The scatter plot below shows displays the resting pulse rate in beats per minute and the time spent exercising in hours per week of 16 students. A least squares line has been fitted to the data. Using the least squares line to model the association between resting pulse rate and time spent exercising, the residual for the student who spent 4 hours per week exercising is closest to. So I've written the formula for the residual over here, which is the actual value minus the predicted value. So we want to find the residual for the student who spent 4 hours per week exercising. So we know the time spent exercising is on the x-axis, so we look for 4. Then we look for the actual value for 4 hours spent exercising. So we know that the dot is the actual value, so the actual value therefore is 63 beats per minute. And the predicted value would be where the least squares regression line is. So from 4 hours to the regression line, that's approximately 64. So minus 64 beats per minute as a predicted. So if you do that, I'll give you -1. So therefore the residual would be -1 beats per minute. Beats per minute. And if we look at the multiple choice options, we have -1 beats per minute over here. So therefore B is the correct answer. Question 8. The equation of the least squares line is closest to. So to do this question, you first have to find 2 points on the least squares regression line. So I just found 1 and 67.2 and 3 and 65. So I wrote those points over here. So first step is to find the gradient of these points. We know that the equation of the least squares regression line is a plus bx. So this value over here would be the gradient. So b would be equal to the value would equal to y2 minus y1 on x2 minus x1. So if you do that, y2, these are the y values over here and these are the x values. So y2 is 67.2 minus 65 on x2 minus x1, which is 1 minus 3. Put that on your calculator and you'll get -1.1. So therefore that's our gradient. So we know that the equation would be y equals a plus a minus 1.1 times x. I'm writing x and y for short, just to save time in writing. But we know that the y value is the resting pulse rate and the x value is the time spent exercising. So if you sub one of the points over here into this equation, you'll find the value of a. So let's just sub 1 and 67.2 into the equation. So 67.2 equals a minus 1.1 times the value of x, which is 1. So if you do that on your calculator and solve for a plus. So if you solve for a in your calculator, you get a equals 68.3. So therefore the equation is y equals 68.3 minus 1.1x. We know the y value is resting pulse rate and x is time spent exercising. So therefore D would be the correct answer, 68.3 minus 1.1 times time spent exercising. So D is the correct answer. Question 9. The coefficient of determination is 0.8339. The correlation coefficient R is closest to. So we know that the coefficient of determination is R squared. So this means that R squared equals 0.8339. We want to find the correlation coefficient, which is the value of R. So that'd be R equals square root 0.8339. It can either be plus or minus, and we have to determine whether the correlation coefficient is either positive or negative. So the correlation coefficient will be positive if the gradient is positive. However, if the gradient of the least squares line is negative, therefore the correlation coefficient will be negative. So we look at the equation that we found from question 8. We know the equation is resting pulse rate equals 68.3 minus 1.1 times time spent exercising. The gradient is -1.1. That's a negative value. So therefore the correlation coefficient would be a negative value because the gradient is obviously negative. So if you put that in your calculator, you'll find the correlation coefficient. So therefore R equals -0.913. So therefore A is the correct answer. Question 10. In a study of the association between a person's height in centimeters and body surface area in square meters, the following least squares line was obtained. Which one of the following is a conclusion that can be made from this least squares line? A. An increase of 1 meter squared in body surface area is associated with an increase in 0.019 centimeters in height. This is a false statement because this is an incorrect interpretation of the slope. It should be an increase of 1 1 centimeter in the height would result in an increase in the body surface area by 0.019 square meters. So therefore A is wrong. B, an increase in 1 centimeters of the height, so increase in 1 centimeters of the height is associated with a 0.019 increase in the body surface area. So that's a correct statement because it's a correct interpretation of the slope. We know that if every time we increase the height by 1, the body surface area will increase by the value of the slope, which is 0.019 meters squared in this case. So therefore B is the correct answer. But we can also check the other answers and we can make conclusions about why they're wrong. So C is obviously wrong because it says the correlation coefficient is 0.019. That's not actually the value of the correlation coefficient. That's the value of the gradient of the least squares line. So therefore C is wrong. A person's body surface area in square centimeters can be determined by adding 1.1 centimeters to their height. So I think this is a false interpretation of the y-intercept, because we can't really make any conclusions about body surface area from about the increase in we can't really make any predictions about the body surface area from the y-intercept, so that's wrong. And that's the same thing for question E. It's a false interpretation of the y-intercept because we can't determine a person's height from the value of the y-intercept. So therefore we are left with B as the correct option. Question 11. Freya uses the following data to generate the scatter plot below. The scatter plot shows the data is non-linear. To linearize the data, Freya applies a reciprocal transformation to the variable y. So that means this transformation over here has been applied to the variable y. She then fits a least squares line to the transformed data with x as the explanatory variable, and the equation of the least squares line is closest to. So we need to determine what the equation of the least squares line is after the reciprocal transformation has been applied to the variable y. So first thing is open up a spreadsheet on your calculator. Once you've done that, you can start entering, you can enter your x and y, and then you enter the numbers for x, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And the numbers for y, 105, 48, 35, 23, 18, 16, 12, 12, 9, 9. And then we want to apply the reciprocal transformation to the variable y. So you can call it you can go up to the top row in the third column and probably write in a variable you want to call it. So you can write reciprocal. We can just write R for reciprocal. And then you enter a fraction here and you write 1 on y, which is your reciprocal transformation, and you hit enter. Then you go down to variable reference and hit OK. And you'll get the following. So we'll enter a list of numbers in for you, which is the reciprocal transformation applied to the variable y. So now we need to determine the equation of the least squares line. So you go to the second row, anywhere in the second row, and you enter, and you press menu 4, 1, 4, and you enter the x variable, which is x, and we enter the y variable as our reciprocal transformation because we have applied the reciprocal transformation to the variable y. So enter your reciprocal transformation to the y list, hit enter, and you'll get the values of a and b. So we know y equals a, we know the reciprocal 1 on y equals a plus bx. So we just got to enter y, a and b. So we know that a is negative 0.0039. And the value of b is 0.012x. So we'll look at the options. Look at the options we have, and therefore A is the correct answer. 1 on y equals negative 0.039 plus 0.012x. Question 12. A log 10y transformation was used to linearize a set of nonlinear bivariate data. A least squares line was then fitted to the transformed data. The equation of this least squares line is as the following. The equation is used to predict the value of y when x equals 1.1. The value of y is closest to. So to do this question, all you need to do is sub the value of x in the equation and solve for y, and you get the value of y. So log 10y equals 3.1 minus 2.3 times x, which is 1.1. If you solve that on your calculator, you go many through 1 if you have a CAS calculator, and you can solve for the value of y. So you enter log 10y equals 3.1 minus 2.3 times 1.1, and you hit comma y, and you'll get the value of y. So y equals 3.7 to 1 decimal place, so therefore E is the correct answer. Question 13, statistical analysis of a set of bivariate data involving variables x and y resulted in the information displayed in the table below. So we have the values of the mean and standard deviation and the equation of the least squares line. Using this information, the value of the correlation coefficient R for the set of bivariate data is closest to. So to do this question, you need to use the formula for the slope, which is over here, which I wrote over here. So the slope or the gradient equals to the correlation coefficient times the standard deviation of y and standard deviation of x. So we know what the slope is, which was given in the equation of least squares line. So we know the slope is 1.31, and we need to find the correlation coefficient. So that's multiplied by the standard deviation of y. We know the standard deviation of y is 3.24. On the standard deviation of x, we know the standard deviation of x is 2.33. So to find the value of r, you just solve on your calculator, and you'll get the value of r to equal 0.94 to 2 decimal places. So therefore D is the correct answer. Question 14. A least squares line is fitted to a set of bivariate data. Another least squares line is fitted with the response and explanatory variables reversed. Which one of the following statistics will not change in value? So the best way to do this question is just trial and error. So we know that just a least squares line has the response and explanatory variables reversed. So first step, we could just create some values for our explanatory variable x and response variable y, and see what happens when we form a least squares regression line, and if the value of the slope changes or the intercept changes, or if the correlation coefficient changes. So we can basically just do trial and error. So let's just enter some random numbers into the x variable. So this is just completely random. I'll just enter 10. So I've entered 10 variables in the x and y list. Now I'll just find the equation using menu 4.1, and I'll find the correlation coefficient as well. So menu 4.1.4. Enter x as x and y in the y list. Hit enter. So A is our value of our y-intercept, and B is the value of our slope, and R is the value of the correlation coefficient. So we want to determine whether any of these would change in value first. So let's just enter. So we'll do the same. We'll use the same variables, but we'll just switch the response and explanatory variable. So I'll show you menu 4.1.4. So instead of putting x in our x list, we'll put y, because the response variable is reversed. Same as the explanatory variable, and we'll put the x variable in the y list. So hit enter, and now we can compare what values have changed. So A, which is the value of our y-intercept, we can see has changed in value. So therefore the intercept of the least squares line changes in value, so therefore E would be wrong. The slope is the value of B, so let's have a look at the slope. The slope has changed in value. It was negative 0.16 at first, and then Now it has, when the response and explanatory variables were reversed, it's become negative 0.14. So therefore that would also be wrong. Let's have a look at the correlation coefficient. As we can see, the correlation coefficient is also the same. So the correlation coefficient hasn't actually changed in value, and we want to know which variable will not change in value. So therefore C is the correct answer. We obviously know that the residual values would change in value because initially the residual values would be determining the distance between an actual y value and a predicted y value, which would change if the x and y variables were switched, because instead of calculating the distance between the y variables, between the actual y variable and the predicted y variable, would be actually calculating the distance between an actual x variable and an actual and a predicted x variable. So therefore that would result in a different residual value. And would also know our predicted values would be different since the slope and the y-intercept of the least squares line has obviously changed. So therefore the predicted values would therefore also change when you sub a value into the equation. So that leaves us with C. So therefore 14C is the correct answer. Question 15. The table below shows the monthly profit in dollars of a new coffee shop for the first 9 months of 2018. Using 4 mean smoothing with centering, the smooth profit for May is closest to. So we need to calculate the 4 mean smoothing with centering for the month of May. So to do this, you'd find the mean from April to July, so these 4 months, and you'd find the mean of March, April, May, and June as well. So first we'll calculate the mean for April, May, June, and July. So that would be 2456 plus 4651 plus 3456 plus 2823 on 4. So that's the 4 mean smoothing for the months of April to July. So do that on your calculator. And you'll get a value of 3,346.5, so that'd be in dollars. And now we'll calculate the the median for the months of March, April, May, and June. So that's 2402 for March, 2456 for April, 4651 for May, and 3456 for June. So do that on your calculator. That'll give you $3,241.25. So now that we've calculated the 2 mean values we needed to find, you basically find the mean value of these 2. So to do that, so once you find the mean of these 2 values, that will basically be the 4 mean smoothing with centering for May. So 3346.5 plus 3241.25. 0.25 on 2, that will give you the mean value. So if you do that on your calculator, you'll get 3294 to the nearest dollar. So therefore B is the correct answer. Question 16. The quarterly sales figures for a large suburban garden center in millions of dollars for 2016 and 2017 are displayed in the table below. Using these sales figures, the seasonal index for quarter 3 is closest to. So we know that the formula for the seasonal index, which I wrote over here, is the actual value for that season or quarter divided by the seasonal average. So basically, first step is to calculate the the seasonal average for 2016 and 2017. So to do this, you add the value of quarter 1, the value of quarter 2, and the value of quarter 3, and the value of quarter 4. Divide that by 4 to find the seasonal average. So if you do that on your calculator, that will give you 2.2925. And the seasonal average for 2017 would be also found using the same method. So you add quarter 1, quarter 2, quarter 3, and quarter 4, and you divide that by 4 to find the seasonal average for 2017. So if you do that in your calculator, you'll get 1.5775 as your seasonal average in millions of dollars. So now we need to calculate the seasonal index for quarter 3 in 2016 and 2017. So for 2016, the seasonal index is the actual value. So the actual value was 3.34 divided by the average, which was 2.2925 for 2016. So if you do that on your calculator, you'll get 1.45 2 decimal places. And the seasonal index for 2017 is use the same formula. So the actual value for quarter 3 2017 was 2.05 on the seasonal average, which was 1.5775. If you do that on your calculator, you'll get so you'll get 1.299. So if you now, to find the seasonal index for quarter 3, you basically have to find the sort of average seasonal index for quarter 3 in 2016 2017. So you do 1.45 plus 1.299, divide that by 2 to find basically the seasonal index for those 2 years. So do that on your calculator, and you'll get 1.378. So it's 2 decimal places, that would be 1.38. So therefore C is the correct answer.